Welcome to our webinar about using a cloud service to manage ship-to-shore communications through multiple networks. We're sponsored today by XipLink, a company which provides the cloud service called Xipnet. Joining us here today are XipLink's Senior Vice Presidents of Sales and Products, Omar Diab and Jakob Botta. If you have any questions, leave them in the Q&A section and we'll get them answered for you at the end of the presentation. Here's Carl Jeffrey from Digital Ship to explain more.
Hello, so we're talking today about using cloud services to manage ship-to-shore communications through multiple networks and how we can make it easier and better. So this is how the cloud service works. We've got data from shore to the ship is routed through a cloud server, which is routing the communications through the best available path to the ship, and it's optimizing the communication. And in the other direction, the data is going from ship to shore. It's going through a hardware device on board the ship, which is itself managed remotely, and that sends data down the best available route. And a communications company, so XipLink in this case, is managing it all. So it should make managing communications through multiple systems much less trouble for shipping company IT managers and much more satisfying for the crew. So crew are going to get faster web browsing and file transfers and uninterrupted communication sessions and smoother videos and more communications for their money. Now, the main reason we're thinking about this is because of Starlink, but there's also other low Earth orbiting satellite services like OneWeb, and many ships are using cellular communications today together with their standard VSAT or L-band. So these services vary in the speeds they give you, the costs, the reliability, the consistency, the latency, and the amount of packet loss, and different services might be more appropriate for doing different things. Now, the XipLink service isn't just about managing multiple communication routes. The software can do other clever things like monitor the data download speeds for commonly used websites like YouTube and find which system works best for each one. There's systems to keep the flow of data packets consistent. So if one system has a dip in the amount of data it can carry for a few seconds, some of the data can be sent through another. And there are times you might want to send important data packets through two systems. For example, if you're doing a video call and switching from one satellite to another, you don't want to drop the call. And XipLink can work with any communications network that can take IP data packets. So although Xipnet is in Montreal, we've got quite an international presentation today. So we're going to start in Dubai. We're going to hear from Omar Diab, who's the Senior Vice President of Sales. He's got a background in network design and wireless networking. Then we're going to go to Johannesburg to hand over to Jakob Botta, who's Senior Vice President of Product. He's got a background in network optimization and compression over wireless networks. We're going to have about 30 minutes of presentation, and then we'll take your questions. Please put your questions in the Q&A box at any time, but we'll take them at the end. And I'd like to invite Omar to start the talk.
Well, thank you, Carl and Farah, for having us today. And I really appreciate everyone joining in today. Thank you for the time. I'm very excited to take you through some of the landscape on the the multi-orbit, multi-path SD-WAN and the system and solution that we've developed to cater for that. So I'm going to be sharing some slides and going through that in a moment. Right, so I'll start off with why do you need to look at a multi-orbit SD-WAN solution to begin with? I think there's a few reasons, but just to highlight, the most important drivers behind multi-path and multi-orbit requirements and the benefits that they bring to the maritime industry. There's a lot of increase of capacity with the introduction of LEO constellations and services, which is providing a big opportunity to the market for a easy, cost-effective way to get higher speeds and better performance. Traditionally, there's the GEO is the main source of connectivity for a long time. And I think that there's a huge demand for bandwidth that's constantly happening. And that demand is, it's unattainable through GEO alone. It becomes challenging, it becomes cost prohibitive. And the introduction of LEOs nowadays with Starlink OneWeb and many more to come, like Kuiper and others, presents a big opportunity. So to capture that, you need to look at something that's able to allow you to capture the high capacity, looking at scalability. There's a lot of new applications that are coming to play. So not just looking at the connectivity part of it, but also looking at the application and providing really high performance and always on networking is very important to manage the connectivity and the solutions to the vessels. Some of these vessels are becoming like floating offices, and a lot of additional applications are being transacted on these vessels. So that's throughput, application performance. Even critical applications need to be managed properly. You get some blockages, you get some adverse weather conditions. All that needs to be factored into play in a multi-orbit, multi-path type of environment. So transition slides here, sorry. So what does the landscape look like really? Traditionally, I guess we've seen GEO as the highest adopted type of connectivity for vessels, but we're seeing more and more diversity in terms of connectivity. So GEO obviously has the multi-bands, the KU, the KA, and even the L band. Also, there's the narrowband factor of the global connectivity. But there's also the MEO constellations with the higher throughput than some of the traditional GEOs, and then now LEO is the global coverage. And then we don't want to dismiss any terrestrial side connectivity for nearshore and onshore connectivity. So 4G and 5G also is something that we consider as part of the multi-path. So multi-path really covers multi-orbit and terrestrial connectivity as that starts growing in demand. The landscape has its different parameters and different challenges. There's different coverages. GEO has a relatively limited footprint compared to some of the global coverages that LEO is providing, for example. Different latencies between the different orbits provides, impact on application performance. Real-time applications might have challenges over high latency links like GEO, which are not there on some of the LEO and the cellular networks. And obviously, the cost plays a big factor into the whole thing. And just to take a snapshot of the most common services or the channels that we're seeing today in the maritime space, I think just to kind of isolate the most popular ones, we're looking at GEO, LEO, and cellular. There are other orbits and links. There's microwave as well that can be factored in. But just to look at these and look at some of the challenges that they pose and some of the pros and cons, GEO is relatively low speed compared to some of the LEO constellations that are coming into play. And they're relatively as well costlier. So just the terminal deployment, the complexity behind the terminal installation, for example, maintenance, and just overall the operational cost behind running a GEO is sometimes prohibitive for a global coverage and for always-on connectivity. It's high latency compared to some of the LEO and cellular connections as well, but it does provide higher reliability, better SLAs, and so on. Looking at LEO, on the other hand, it's much easier to deploy. It's a higher speed. It provides a global coverage from the get-go. It has significantly lower latency than the GEO, so you can expect a lot better performance on some of the applications, especially real-time, voice, video streaming, video conferencing applications, just to name a few. But it does have some challenges in terms of stability. There's a lot of satellite handover. There's a lot of things happening in orbit between the LEO satellites that could affect the stability and the performance of these links. So that has to also be factored in when looking at a multi-orbit environment or a connectivity solution. And then cellular, of course, the limitation is on the coverage, right? You have to be near shore to be able to connect to most of the cellular networks. And it's generally more congested as a terrestrial connection. And it has the kind of variable nature based on peak time congestion and so on. So, you know, it's also lower latency than some of the geo typically. So with that said, you know, we always need to look at these different challenges and different factors that are coming into play when considering what kind of connectivity and what kind of different links that we're dealing with when looking at an SD-WAN multi-orbit solution ultimately. And in addition to that, you need to make sure that the solution that you're adopting, you know, understands the nature of the paths and the orbits that are in play, right? So you need to understand the stuff that we just talked about in terms of challenges and capabilities and take advantage of those. The important part is it has to happen automatically. It has to happen seamlessly. It's not scalable or feasible if, you know, everything is managed manually. You're disconnecting one, connecting another, or having a specific service on a specific link, and then that link goes down, takes the service down with it. You want to have something that's always on, managing these connections automatically in a seamless kind of way. And it has to be scalable. It has to be scalable in terms of capacity, it has to be scalable in terms of you know, the number of vessels, the number of users that are behind these links as well. And that plays a big role in application performance as well. So look for something that understands what's happening on the application layer, not just a raw connectivity type of solution. You know, the applications nowadays, they're cloud-based. They connect to so many different POPs all over the world, you know, from Teams to internet browsing to, you know, video streaming applications. You know, the solution that you should look at should understand the applications and how they behave and be able to really make decisions on where these applications have to pass through to make sure that the performance is optimal. And obviously keeping a finger on the pulse of everything and making sure that the user experience is enhanced. And there are some technologies that could come into play, you know, compression and acceleration technologies that could directly impact the user experience. And this is not what's happening on the link side as much as what's happening on the application side and the traffic side of things that the user is directly involved with. So faster page load speeds, faster file transfers. This is the kind of experience that the user really is looking out for when you know, when selecting a proper connectivity solution. Monitoring is an important one. So reporting, monitoring, and statistics behind what's happening, right? You have all these multiple paths with all these different applications running all at the same time. You want to make sure that everything is running smoothly. You want to be able to have the right people look at things, you know, if something goes wrong, quickly recover from that, and having those stats and analytics available is crucial, especially looking at a regional or global service. And finally, last but not least by any means, is the cost management. Ultimately, lowering the total cost of ownership of the service is important without impacting the quality and the user experience is challenging. So just make sure that the service and the solution has cost in mind, and you know, and making sure that the quality as well is not affected by, you know, dropping that cost. So we've discussed why an organization may need multiple orbit solutions and what one should look for in an SD-WAN technology that helps manage services and applications across these links and these services. And Xipnet from XipLink has been designed from the ground up to address these requirements, and includes many enhancements that leverages our 2 decades of experience and our heritage from the satellite world. And with that said, I'd like to transition and introduce my colleague, Jaco Bota. He is our SVP of product. He's the brains behind Xipnet and the chief architect for our solution. So I give you Jaco. Thank you very much.
Thank you, Omar. Hello, everyone, and thank you very much for joining us today. Omar, I'm going to rely on you to transition the slides for me, please.
Sure.
I see a long delay in if I controlled it myself.
Yeah, that's fine.
If you could maybe transition to the that slide. Yes, that's correct. So I'm very thrilled to announce and introduce our Xipnet multi-orbit SD-WAN cloud service today. And I'd like to also show you how Xipnet is more than just an SD-WAN service, and how it provides the features and the values that were highlighted by Omar. So Xipnet connects remote networks to the cloud, and it's possible to use all of the available internet service connections at the same time, delivering the best internet experience possible from anywhere. The underlying links could be any internet protocol links or IP links. And it's important to note that these links are not provided by XipLink or Xipnet, and that allows the owners or partners to decide what services make the most sense for each individual situation. And you could have different services that are active in different regions, and we can combine all of them up to 24 different services on a single platform. You'll see that there's an edge device on the left-hand side of the diagram that is used to connect to the different services. You have, potentially Starlink, OneWeb, LTE or 5G, ship-to-shore microwave, geostationary satellite connectivity, and so on. All of these links have different properties, but what the Xipnet Edge device will do is automatically manage the traffic going over these links, and then terminate that into a point of presence on the cloud side. And the important values that this provides is up to a gigabit of aggregate capacity for each remote network. Application performance optimization is built in. We provide uninterrupted connection management or session movement between different links. So let's say you have multiple Starlink terminals on a vessel, for instance. If you turn around, as your ship maneuvers, you might find that one of the terminals or the antennas are obscured, and then that link will fade or go down, and the Xipnet service will automatically detect that and move all the traffic seamlessly over to the other side. So this gives you not only service diversity, but also intelligent link estimation that constantly monitors all the links and provides the best quality of service over these links. Can you go to the next slide, please, Omar? The points of presence that we have are located in high-speed internet exchange points, and we have a high bandwidth internet connectivity from these POPs. So right now we have 5 POPs live, 3 of them in the US, 2 in Europe. But we're constantly looking for additional POPs, and as we grow the network, as we grow the customer base, and more regions come online, we'll be able to expand POPs in a very short period of time. So the bandwidth available at each POP can be scaled. It's as I've said, they're directly connected to the backbone of the internet. So we don't have any data caps, and we have a very liberal fair usage policy for the service. Can you go to the next slide, please?
Yeah, just we have one request to raise your voice a bit. I think that's a bit low. Just wanted to let you know. Thanks.
Okay, is that better?
Yeah.
All right.
Thanks.
Okay, I'll talk a little louder. The service is delivered from edge devices. So you have the Xipnet edge devices. We have two models, the XH10 and the XH100. The XH10 provides service up to 250 megabits per second. So, that it also has multiple Ethernet ports that you can connect to the services or the modems. And if you want to expand to more connections than what are available, then you can use an external VLAN switch to do that. The XH100 provides service up to 1 gigabits per second, and the important part here is that this is a remote edge platform that is centrally managed from the cloud, and it's something that typically you don't need to worry about, but it also provides a lot of scalability and additional capacity to be even used for additional partner services that can run on this edge device. Can you go to the next slide, please, Omar? Okay, so our Xipnet service is monitored not only by a back-end system that runs in the cloud, but also it's possible to monitor the service from the vessel. So on a local LAN, we have the Xipnet app that gives you a number of different features. So these features are for instance, measuring the speed that the services is delivering on a regular basis, providing a view of which POPs are available and which POPs are, what the round trip time to the different POPs are. It allows you to connect to a different POP if you want, and this could be as a result of moving into a different region where it makes sense to maybe connect to a different POP, or it might be that you want to get your internet serviced from a specific geographic region, and that then would allow you to do that as well. Excuse me. We also have a number of performance metrics like the video and web page performance. We constantly show, how much are we improving the service over a standard network link. We also have performance monitoring of our aggregate and the individual link performance. Can you go to the next slide, please, Omar? So I'd like to tell you a little bit about the underlying technologies that we use to deliver this service. XipLink has been in the business of optimizing satellite and wireless network connectivity for a very long time. In fact, for more than 2 decades. And we're bringing to bear all of these technologies. So the first one that's obviously important is link balancing and bonding. So making sure that the traffic can go over all of the links at once. This is not just a failover service, it's a concurrent performance optimization and balancing act between the different links. So one of the things that XipLink really excels at is to maximize the traffic flow. On a network like Starlink, for instance, it's actually a very hostile environment for internet connectivity. Even though it provides high bandwidth, it's not so easy to achieve high bandwidth at all times. The service is very, very widely variable, and the throughput of connectivity is impacted a lot by the amount of loss due to satellite handover and due to congestion on the network. So we've developed algorithms that accelerate the traffic and perform, as best we can, as best as possible on these links, and we'll adapt to whatever link is available and in use at the time. So traffic is accelerated and optimized across the network, and it also provides the the maximum traffic flow, and we also do traffic steering of different applications, so that if certain applications require, let's say, more or lower latency or less packet loss, maybe some applications are very prone to packet loss, then we could steer them across. But another thing, Omar, if you go to the next slide, please. Another thing that we do is we also are able to duplicate traffic by using intelligent stream traffic spreading. So that means, for instance, that for example, an application like Teams or Zoom would use connectionless traffic stream that's going over the link, but if packets drop, then you might have a loss of performance, and you might have breakups in the video or audio. But if you send the traffic over multiple links at the same time, then one of them is bound to get through, even if the other one gets dropped. So this is what we do with intelligent traffic spreading. We also do application-aware quality of service and firewalling. And later this year, we'll be adding extra level of application awareness and even artificial intelligence to detect applications that are encrypted and obscured by standard internet encryption mechanisms. Of course, the service provides redundancy, just by the fact that you have multiple links that can be used, that you can back up, links as required. And this is not only for, the whole link, but it can also be for a specific application. So some applications you might want to use in a non-stop way, but other applications, you may not want to continue offering service if there's, let's say, very limited bandwidth, and only want to fail over the most critical applications. Another benefit is to have service overflow. So let's say you have a bulk link with low cost, then you want to use that up to the maximum capacity. But if you then require additional capacity for a period of time, then you could allow service overflow in peak periods of time. But you know, even if it's a slightly more costly link, it would still provide the required service. Next slide, please, Omar. So to summarize, I think we're providing a gigabit performance and very scalable service. It's important to note that our go-to-market strategy is to provide this via partners. So we'd like to invite you to talk to us to identify the most appropriate partner for this service. We have optimization built into the service. This gives us the best application performance. Omar, sorry, are you still sharing the slide? It's disappeared on my screen. There you go. Thank you. The built-in optimization provides consistent service even over LEO links. It's cost-effective. The data, you know, we don't have any hard data caps on the service. We have a monthly plan, and it's possible to suspend the service in off-season periods. So you don't want to pay for a service when your vessel is in storage. So that's a possibility. The flexibility of the service is quite unparalleled. We can use any available internet link, and we can do it anywhere in the world. And the net effect of all of these benefits and features that we provide is that the end user experiences faster internet connection, and the benefit to the service provider partners is that the links are utilized as efficiently as possible, and we provide the maximum throughput. So as I've mentioned, this service is available today, and we would love to talk to you and identify the appropriate partners. And please get in touch with us on that. Thank you. That's my bit. Handing you back to Cole.
Oh, fantastic. Okay, so we'll go to the Q&A session. So we've got one question so far, but if anybody wants to put questions in the Q&A box, otherwise I've got a few of my own. So there's one question from Ian McKenzie, who's an instrumentation engineer. So he's asking for more detail about how the edge device chooses which service to use. I think you might have presented this after he showed the question. So you're showing the different ways of flowing, but also perhaps you can talk about, I mean, is there a choice if it's like crew communications goes one way and business communications goes another way? Is that do you want to?
Yeah, that's one possibility, is to separate by type of communications. For instance, if you have different networks on the ship that you know, could be, let's say, some of them come from the crew, some of them come from the instrumentation, some of that comes from you know, business traffic. So typically those come from different networks, so we can select on those different networks and apply different policies to the different types of traffic. And then on top of that, you know, automatically we would detect the link bandwidth and the link performance, and then we would adjust the traffic policies dynamically based on the actual link performance. So it's not just a static allocation that says this goes there, but this goes there if the link is good enough, or this goes there if there's not too high a packet loss on that link, and then use alternative links in that case.
Is it something the customer can configure themselves if they want certain communications to go in a certain way? Or?
Typically, this is something that the partner, the service provider partner that we work with, would configure. And there are limited amounts of configuration that can be done by the end customer, but it's generally not something that you want to change on a day-by-day basis. So we'd love to understand the environment better if there's a requirement for making changes on a regular basis. We're constantly improving the service, and we can roll out updates remotely. So if features are specifically required, then we can definitely talk about it and expand that.
Okay, so we've got a second question from Ab Argam, who's from Inmarsat. I don't actually understand his question myself, but perhaps you do. He says, does it manage aggregation of the available capacity through different carriers simultaneously? Do you understand what his question means? Or
the short answer is yes. I think it's important to note that we operate at the Internet Protocol or IP layer. So when you talk about carriers, that's talking about the RF side of things. And for us, the RF carriers, translate into different equipment that is generally called a modem. So we interface to the modem. The modem talks to the antenna and to the satellite, and uses multiple carriers. So if you have two modems across multiple carriers, then we would be able to aggregate that. But we do not provide any RF based services. So I hope that answers your question there.
Okay, so Fulvio Sansone, who's from a satellite company called Nexsat in Brussels, asking, why do you need to route the user traffic to your point of presence if the I've lost the question. If the oops, Q&A, bring it back. If the remote device applies a chosen traffic policy, this might be potential latency addition. So I guess is it Starlink wants to go to one point of presence, and Inmarsat wants a different one, is that?
The important thing to understand here is that Starlink also has multiple points of presence across the world, and any other LEO satellite service will also have different points of presence. So these the traffic is routed through a point of presence anyway. And what we've done is we've located our points of presence close to Starlink. The benefit of doing it this way is that when the traffic goes through our POP, we have much more control. If we only send traffic, and lots of solutions do this, they use what's called a direct internet access link balancing solution. But the problem is that with that, you are basically your traffic is stuck on one path once it's selected to go on that path, because you don't have any control over the traffic on the cloud side of the link. So I hope that answers your question. It's a design choice that we've made, but we could provide direct internet access services as well, if that's more beneficial to the specific use case.
Okay, so we're going to go to Emily Kwek, who's a pricing manager with Singapore Telecommunications, Singtel. Any roadmap for security features I've been Googling some of these letters. I've got DLP means data loss prevention. I don't know, IPS and NAV. Perhaps you know what they mean. And any future for crew internet management?
I know what DLP means, and it's important for enterprise customers. We primarily focused on connectivity side of things, and because this is a cloud service, we can relatively easily plug into other cloud security services. So if you need those type of enterprise security services, then we can collaborate with other cloud security services. We do provide basic security, but we may not have all the bits and pieces that you would need, and that would be relatively easy to expand by combining services.
Oh, so Roger Go is a product manager with Singtel in Singapore. Yes, same question about managing the traffic and usage on the LAN side, which I presume means the ship side. So business communications, Internet of Things, sensor data, crew data. I guess you answered that before, saying you could build this, but you want more input about what people want. Is that a...
Well, the crew data, the different networks on the ship, that part's already covered, and we can definitely, based on where the traffic comes from on the ship, we can control where it goes. I think it's just a matter of understanding the requirements and setting up the policies accordingly.
Okay, so Sandeep Sequera, he's from OneNet, and I think they're in Cyprus. Do I need to maintain Infinity Exchange? Do you know what they are? I just asked Google and I didn't know. So, do you know what Infinity and Exchange are? Or...
I don't. Mara, I don't.
Yeah, that might be the aggregator that Marlink might be using, if I'm not mistaken.
Okay, maybe Sandeep, you can let us know what Infinity Exchange are. Okay. Class.
Yeah, I guess no, I mean, Xipnet is quite comprehensive in terms of managing the multi-paths to the ship, and like Jaco mentioned earlier, any additional applications that you might need in terms of spinning up a firewall or any specific intrusion prevention or crew welfare, quota management, specific kind of software that can be easily overlaid, whether you're using your own or we would mutually identify something that works for you and your fleet. Again, it's a cloud-based service, so we would potentially look into spinning it up on top of what Xipnet is providing on the connectivity layer and the features and capabilities that Jaco went into in detail. So we advise that if you do have any specific interest, you can reach out to us, and we'd be happy to take the conversation further for sure.
Okay, so Reza Mehanzadeh is a commercial and projects manager with the Industrial Engineering Service Company of Iran. He's asking about approvals from the International Association of Class Societies. I know you don't have that much. Your more background is in other industries of shipping, so perhaps you're not so... I don't know if there's something you know much about the approvals from maritime class societies.
Since our service is an overview, an overlay service, I think that when it comes to the actual connectivity, that would be something that you discuss with your service provider or the various service providers that are providing connectivity to your vessel or your fleet. What we would do is we would manage as an overlay cloud service, but we're not actually providing the links themselves. I hope that answers that question, Reza.
Yeah, I think so. Emily is asking more information about the crew internet service. So you said you've got a service for crew to... I don't know if you want to give any more, but you already explained it a little bit, I think, Jaco, didn't you?
Yeah, maybe Jaco, you can give some highlights of what we're planning in terms of some of the quota management, crew welfare, system that we're looking into as part of the OSS BSS and some of the features there, capabilities there.
so we have a number of different initiatives that we want to provide as part of XipNet itself. But as a starting point, there may be as we move into the market, our partners may already have a crew welfare and internet service provision. We would ideally just slot into that. But if that's not available, or on maybe smaller vessels, then we will provide an overlay quota management system, and we can also provide differentiated services, even to the point where we could provide a ticket-based or a voucher-based access to crew for accessing the service. And we would always do this in conjunction with our partner that is reselling or providing the service to the ship owners.
Oh, something I'd love to ask you, Jaco. Your experience with Starlink, because it's very hard, I think, for most people in the industry to find out any independent perspective on how good Starlink actually is. Starlink themselves don't say anything or offer any quality of service. I know this is slightly off topic, but you mentioned impact by, you said floss or froth. I mean, how good is Starlink? Do you think shipping companies can rely on it 80% of the time potentially, or is it possible to answer at all? Do you think?
Yeah, I think what's amazing about Starlink is that it's grown so fast. I think we're at 2.7 million terminals at the moment.
Wow.
I mean, that's something that is really rivaling the total of the number of satellites that Starlink fly. Is far outstrips the number of geostationary satellites. The number of terminals, is just humongous. But that comes with some downsides as well. So it's a very popular service. So every now and then, it becomes really congested, and then Starlink does something to improve, and then it becomes better again. What you get from Starlink today and what you get from Starlink tomorrow might be something very different. And then there's another aspect to it. What we know, and this is not proprietary knowledge because we don't have any relationship with Starlink, but what we know is that the Starlink network changes every 15 seconds.
Wow.
The round trip time might vary from 20 milliseconds to 80 milliseconds on a second-by-second basis. The amount of packet loss is generally pretty high. It's typically more than 1%, which is unheard of in a geostationary world. There you have very, very low 0.01% packet loss typically. So it's a very different environment, and actually pretty hostile to TCP/IP traffic. So the throughput that you can achieve typically on a Starlink network, is much lower. Single connection throughput is much lower than the total bandwidth. Now, if you have hundreds of users, maybe that's not so important. But if you need to get a file transfer across, then it becomes really important. So the bottom line is Starlink is pretty pervasive. It's very successful. It's easy to install. For the most part, it can be installed by, you don't need a specialist installer like for geostationary satellite VSATs and stuff like that. It's been phenomenally successful actually. So I think it creates a huge opportunity. But so does OneWeb, and so will Kuiper, and all of these new services. It's a brave new world for satellite connectivity going forward in the next few years, I think.
Losing 1% of your data packets, I suppose it resends them, so you don't actually notice anything, but it makes it a bit slower, does it? Or is it?
Yeah, the problem is that the way the, let's say, TCP/IP protocol works is when it loses a packet, it doesn't know, TCP/IP doesn't know whether that packet is lost because it's sent too much data and the bandwidth and there's now congestion, or whether the packet was lost because of a satellite handover. So usually TCP/IP would take the conservative choice and say, this packet was lost because of of congestion, so it would back down the rate at which it's sending, and this causes that the throughput can sometimes be quite terrible if you have you know, high packet loss on any kind of network link. But Starlink's packet loss is exceptionally high as far as you know, wireless networking is concerned.
Oh, and another question on the cost management, because the shipping companies can be very cost sensitive, particularly crew sending personal communications. So a shipping company might allocate a crew member a gigabyte for a month, but they want to use every single data packet of that. But does your service let them get more for their money by squeezing more packets through the same number of megabytes somehow? Or is it?
We do a little bit of that, but the compression side of our optimization is challenged by the pervasive use of SSL or TLS traffic. So, you know, if you open a web browser, your web browser is more than likely going to have an encrypted session with Google and with any other website that you're connected to. And that encryption prevents us from compressing the traffic. So there is a little bit of compression. We do also perform compression on packet headers and things like that, but it's not significant. So from a compression point of view, I think that's not something that we add a lot of value for general internet traffic. However, we do add a lot of value with quality of service, fairness of connections, and we can control the amount of bandwidth that's in use by the different users on the ship, for instance, so that you know, you can get a really good service even at a limited bandwidth, and even you know, control the amount of gigabytes that can be used by a specific class of users.
Yeah, and then maybe on the other side, there's a lot of talk in shipping about autonomous ships, where I guess if you're controlling a ship by satellite, then it's absolutely completely essential that a certain data communications gets there reliably. And I guess services like yours can do a lot to make sure that happens, isn't it?
I hope so, yes.
It seems to me that where the shipping industry is heading, this kind of expertise is going to be more and more vital. We're going to have a lot of our crew doing video calls and a lot of super important data that's got to get there, and business people want to do communication with the ships, and everything's got to work. And
seeing that already, and you know, people run their businesses from their ships, so I think that's already happening, and I think the thirst for bandwidth is insatiable, basically. So it just keeps on growing and growing, and people want reliable networking, and that's what we provide.
yeah, I mean, Omar, you haven't said anything for a little while, but maybe since you're on the sales side, do you want to talk a little bit about how the clients themselves are using it? That's something we haven't.
Yeah, I think Jaco covered a lot on the technology side and some of the applications and you know, the things that we're looking at from that perspective. But yeah, from a market and business perspective, I think it's very important to listen to you know, what the user really wants to achieve, right? Like you said, Jaco, the demand for bandwidth is always on the rise, and you know, this is the #1 driver for adoption of these high-speed, cost-effective LEO services like Starlink. But it's not something that's intuitively done, right? A lot of people have adopted Starlinks and still trying to figure out what they can do with it. It's a global consumer platform that is, you know, in hopes of getting adoption into bringing in some professional connectivity to some of the fleets and vessels. So, you know, we understand what the application requirements are. We understand what kind of users are on these vessels. And even on a single vessel, it could be just a variety of different applications at the same time. So from browsing to just, you know, tracking and telemetry and some really critical applications that are happening. And it's important to keep cost in mind as well, right? You know, the way we're providing this, it's a monthly service, and it's important to focus on this a little bit. You know, we don't want to be an annual burden. We understand the seasonal nature of some of these vessels, so we want to cater to that. We understand that some of these services that are coming into play are metered services, you know, so people want to stay within the monthly quotas. You don't want to necessarily accrue any additional cost if they can avoid that by exceeding their quotas, for example, or unnecessarily metering just for some chatty applications that are happening, but no real use behind them. So we're very conscious of that, and we put in a lot of the features and stuff that Jaco keeps busy with to make sure that that's handled properly. Yeah, and then you know, the go-to-market approach is quite important as well. You know, we are looking more on the technology side and obviously understanding the market, but we do rely on service providers to provide the connectivity, to provide this as an overlay service. I think one of the questions that came in was, you know, can I maintain some of the IT services that I have on the you know, my ships today with the Xipnet service? And the answer is yes. And we are a transparent overlay service that enables you to continue doing what you're doing, but enhancing the connectivity and the underlying services that you guys are using anyway, and the ability to add more services as you get more bandwidth demand from your crew and from your customers as well, right? So it's a big opportunity, and we're looking at constantly enhancing what we're doing. And we really love the feedback from the users of the services, really to help us continue to enhance and build on and to give you guys what you need at the end of the day. Again, in a cost-effective, easy to digest a manner, right?
Well, we've just got about a minute left, but so if a company is using Starlink and Inmarsat, for example, as many companies are, they're finding it a struggle to manage, they should contact you and discuss your service to help you manage it. I guess that's
100%. Absolutely. Yeah.
Well, that's great. Well, I think we've
Always,
seen a
open to these conversations for sure.
Yeah, that's great. I think we've seen a vision of the future. I can't imagine how the future can manage without services like this, as everything gets more complicated and the demands get bigger. So thank you very much, Jaco and Omar. I think that's fascinating.
Thank you very much.
Shall thank you, and I shall pass back to Farah for the closing words. Cheers.
Thank you very much.
Oh.
Bye, everyone.
Thank you.
Thank you to our speakers, Omar and Jaco from XipLink, and to all our viewers. We'll be sending you a YouTube video link soon with contact details if you have any further questions. Join us for our next webinar on the 13th of June with KVH. You can find the link in the chat section or register on our website. Goodbye.
Thank you. Bye-bye.